Very good morning, dear friends. Myself, Dr. Vikrant Sudhakar Palekar. I am working as an assistant professor in Gokhale Education Society's Arts, Commerce and Science College, Jawahar, Palghar. Welcome on the topic Chemical Thermodynamics. Till in this particular topic, we have understood various different terms related with the, let us say, system, surrounding, then various different processes which are carried out at different parameters such as isothermal process, isobaric process, isochoric process, what is reversible. Then in the last few sessions we have also understood few laws of thermodynamics, and till now we have also seen some of the terms such as work, heat and internal energy. As we know that heat is the form of thermal energy which is associated with the system, or we can say it is contained inside the system. When system change from one state into another state, there is occur change in the heat content which is associated with the system. And as a result of flow of heat around the boundary of the system, there occurs a change in the system. So that is being associated with the work done. So we can define that particular work in the form of compression or expansion. And then we have also understood what is the mean by the term internal energy. As internal energy is nothing but the sum of all the energies which are associated with the system. Let us say vibrational energy, rotational energy, that may be let us say translation energy. So these are the three terms which are very important, and these three terms which are confined in particular law, that is being called as the first law of thermodynamics. Then along with these particular terms, we also understood the various different sign conventions in order to denote these particular terms. As if we say Q, it is denoted with the sign heat, that is positive, then we can say heat flow from surrounding into system. If it is say, let us say negative, then heat flow from system into surrounding. Then W, whenever there is a compression, so what will happen? Work is done on the system. In that case, W will be positive. And in the process of expansion, so what will happen in the case of the expansion? The volume increases. So work is done by the system. So that in that case, work will be the W. And if we say the delta E is having negative value, so in that case what must happen? Heat must have flow from system into surrounding. So as a result of that will be exothermic reaction. Whenever the delta E is negative, that means heat system में से बाहर जाती है, that is being called as heat system में से heat बाहर पड़ती है, that is being called as a exothermic reaction. Endothermic process, in that case the heat flows or internal energy is positive. So in that case we can say that particular process is endothermic reaction. And we also understood some mathematical expression of first law of thermodynamics, that is being given as the change in internal energy is the sum of heat plus W. So this is a mathematical expression of first law of thermodynamics. We have also derived this particular equation in the last few sessions. So remember this particular equation, which will help to understand the next term. Today we are going to understand a very important term that is being called as a change in enthalpy. So that is denoted by the H. Correct, here must be H. So basically whenever a chemical or physical process is carried out at constant pressure, the heat is supplied in order to increase the internal energy and doing the work of expansion. As we know that whenever in a open system that particular process takes place, that is at constant pressure. So what happens at constant pressure? Heat is supplied. Suppose if we supplied some amount of heat to the system, so what will happen in that case? Whatever the matter present inside the system, it will help to increase the internal energy of that molecule, and as a result of that there will the expansion. Suppose अगर गैस एक कंटेनर है, उसमें गैस लिया है, उसको ऊपर से पिस्टन लगाया है और नीचे से हमने बर्नर से हीट सप्लाई की. सो व्हाट विल हैपन? अल्टीमेटली जो गैस मॉलिक्यूल्स रहेंगे कंटेनर में उसको एक्स्ट्रा एनर्जी मिलेगी. एज अ रिजल्ट ऑफ दैट देयर मोशन, रैंडम मोशन विल इंक्रीज, एंड एज अ रिजल्ट ऑफ दैट द वॉल्यूम विल इंक्रीज. Okay, so that will result into the process of expansion. So as we know that as per the first law of thermodynamics, what we can write? So in that case, internal energy, how can we calculate? The change in internal energy is nothing but heat supplied, जो जितनी amount of heat हम supply करेंगे plus जितना work होगा. So delta E is equal to Q plus W. So in the process of expansion, what will happen? In the case of expansion, so delta must be negative. Here we can write negative also. So as we know that this particular process is carried out at constant pressure. जितनी भी प्रोसेस ओपन सिस्टम में की जाती है, ओपन एटमॉस्फेयर में, उसका प्रेशर कांस्टेंट रहता है. सपोज अगर हमने यहाँ पे टेबल पे एक बीकर रख दिया, so that will having the constant pressure. प्रेशर उसका कम ज़्यादा नहीं होगा. So in that case the heat Q, in case of the delta E we can write Q, because delta is directly related with the quantity of heat supplied at constant pressure plus delta E plus P delta V. Instead of W, वर्क हम लोग कैसे डिफाइन करते हैं? वर्क इज इक्वल टू फोर्स इनटू डिस्प्लेसमेंट. सो इन दैट कनेक्शन वी कैन राइट हाउ मच इज द फोर्स, the pressure what we have applied, and then change in its volume. Suppose volume changes from V1 to V2. So we can write same equation in this particular format. Suppose if we write instead of delta E मतलब क्या? The change in internal energy, that will be in the change in internal energy from final state minus change in internal energy into initial state. So we can write this particular equation in the form of E2 minus E1. As we are carrying out this particular process at constant pressure, so it will be V2 minus V1, change in volume. अगर हम लोग ये जो टर्म्स है एक साइड लेंगे, E2 and PV2 एक साइड में, और ये जो टर्म है एक साइड में, so we get a thermodynamic quantity that is E plus PV. यहाँ पे भी क्या है? E यहाँ पे प्लस होना चाहिए साइन, E प्लस PV, करेक्ट. यहाँ पे P साइन मस्ट बी पॉजिटिव. सो इट इज़ नथिंग बट व्हाट? हीट कंटेंट. सो बेसिकली एंथैल्पी हम लोग क्या बोल सकते हैं? इट इज़ अ हीट कंटेंट विच इज़ एसोसिएटेड विद द सिस्टम एंड इट इज़ बीइंग डिनोटेड एज E प्लस PV. इन शॉर्ट में एंथैल्पी आपको एक छोटा सा एग्जांपल देके समझाता हूँ. सपोज अगर कोई कंटेनर है, उसमें कोई गैस मॉलिक्यूल्स है, and as a result of that this gas molecules having some energy. So that particular gas molecules when confined in one particular system, they are having a heat content which is associated with the system. And how to calculate its heat content or enthalpy? That is nothing but sum of its internal energy, that is nothing but E plus pressure and volume terms if they are being variables. So remember definition of enthalpy, it is nothing but in the form of equation H is equal to E plus PV. माइंड में अभी फिक्स कर लो कि what is mean by enthalpy. It is nothing but E plus PV, internal energy plus pressure volume. So it is a sum of internal energy and pressure volume work at constant pressure. So remember it is a E plus pressure volume work at which is being carried out at constant pressure. So the quantities E, P and V are state function, therefore enthalpy is also state function. What is the symbol for enthalpy is H. So hope so you understood what is meant by enthalpy. Enthalpy is nothing but the heat content which is associated with the system, which can be calculated as a sum of internal energy plus pressure volume type of work. Remember H is equal to E plus PV. Suppose if you want to calculate the change in enthalpy, that is delta H. अगर कोई भी केमिकल प्रोसेस होती है फ्रॉम स्टेट 1 टू सिस्टम, सपोज हम लोग रिएक्शन पकड़ लेते हैं जहाँ पे रिएक्टेंट्स कन्वर्ट होंगे प्रोडक्ट्स में. सो उस टाइम में क्या होता है, सिस्टम की कुछ तो इनिशियल एंथैल्पी होंगी H1 और फाइनल एंथैल्पी होंगी H2. Suppose if you consider H1 is the enthalpy of the system at initial state, that is reactant, that will be calculated as H1 is equal to E1 plus PV. यहाँ पे P हम लोग कांस्टेंट रखते हैं तो P लिखेंगे, अगर हम लोग प्रेशर भी वेरी कर ले तो P1 V1 ऑल्सो वी कैन राइट. सो H1 इज इक्वल टू E1 प्लस PV1. इन द फाइनल स्टेट H2 इज इक्वल टू E2 plus PV2. ये समझ आया ना. So it is nothing but this particular quantity is the enthalpy at initial state. This particular quantity is the enthalpy at final state. So change in enthalpy कैसे calculate करेंगे? Delta H कैसे calculate करेंगे? It is nothing but the difference between final state of enthalpy minus enthalpy at initial state. That is nothing but H2 minus H1. If you put the values of H2 and H1, as we know already the values of H2 and H1 in this particular equation. So this particular equation can be H2 minus E1 is equal to H2 minus H1 is equal to E2 plus PV2. यहाँ पे ये quantity यहाँ पे ली. H1 की quantity already we know E1 plus P1. So same जो quantity है, मतलब internal energy, volume हम लोग एक साइड कर लेंगे. So let us arrange this particular equation in the form of E2 minus E1 plus PV2 minus P1. So E2 minus E1 के लिए हम लोग क्या लिख सकते हैं? अगर यहाँ पे प्रेशर कांस्टेंट है तो ये टर्म हम लोग ब्रैकेट से बाहर ले लेंगे, तो ये टर्म क्या हो जाएंगे? So this particular equation is equal to delta H is equal to E2 minus E1 plus V2 minus V1. ये इक्वेशन को हम लोग कैसे लिख सकते हैं? ऐसे भी लिख सकते हैं. डेल्टा H, ये डेल्टा H इज इक्वल टू E2 माइनस E1 के क्या लिख सकते हैं? चेंज इन इंटरनल एनर्जी प्लस P. V2 माइनस V1 को क्या लिख सकते हैं? डेल्टा V. सो हाउ टू कैलकुलेट द चेंज इन एंथैल्पी? सो इट इज नथिंग बट delta E plus P delta V. So this particular equation will help you to calculate the enthalpy at constant pressure. Suppose if you are not maintaining the constant pressure, then this particular equation also we can write. Suppose pressure and volume both are variable, then this equation can be delta H is equal to delta E plus delta in the bracket PV. Both are variable. If you are maintaining volume as a constant, then this equation will become delta H is equal to delta E plus V into delta P. So depending upon the variables parameters, you can write this particular equation, but most of the open system cases the pressure is kept constant. Now we want to extrapolate the sign convention for the enthalpy change. As we know that delta H is equal to H2 minus H1. So suppose if you want to assign whether this particular process is exothermic. सपोज कोई भी प्रोसेस होती है उसमें हीट बाहर जाती है सिस्टम में से, या हीट अंदर से बाहर आती है, बाहर से अंदर आती है, तो बेस्ड अपॉन दैट वी कैन राइट. एज वी नो दैट एक्सोथर्मिक केस रिएक्शन में क्या होगा? H1, the value of H1 will be greater than H2. So in that case delta H will be negative. So whenever the heat is evolved मतलब क्या? हीट सिस्टम में से बाहर जाती है. So in that case we can say that particular process is exothermic reaction. Suppose आप कहाँ पे भी बुक में साइन देखते हैं delta H is having negative value. So what you have to understood in the mind that in this particular reaction heat must be given out from system to the surrounding. So there must be heat evolved. Many times हम लोग जब पानी में कुछ तो अगर सपोज डालते हैं तो वहाँ पे क्या होता है? हीट जनरेट होती है और दैट पर्टिकुलर हीट इज बीइंग इवॉल्व्ड. शुरुआत को टेम्परेचर ज़्यादा रहता है, फिर बाद में कम हो जाता है. सो इन दैट केस वी कैन से हीट इज इवॉल्व्ड. Suppose if you take the example, if you mix solid carbon plus oxygen gas, so what is being formed? Carbon dioxide, and along with the formation of carbon dioxide gas there occurs the evolution of heat. So that particular heat we can calculate, and that is being assumed to be minus 393.5 kilojoules. So when we see this particular sign as a negative, what we have to understand, this particular reaction is exothermic. there must be heat evolved during this particular process. Then if the process is endothermic, suppose H2 is having higher value than H1, suppose H2 20 है और H1 10 है, so 20 minus 10 is equal to plus 10, so delta H is having positive value. So a reaction in which heat is absorbed when the reactants are converted into products. So this ये प्रोसेस में क्या होगा, सिस्टम एब्सॉर्ब करेंगे हीट. कहाँ से करेंगे सिस्टम एब्सॉर्ब? सराउंडिंग से. सो व्हेनेवर nitrogen, here must be N2 plus O2 gives twice NO. So delta H is having plus 180.8 kilojoules. So whenever there is a plus sign, what we must understand, this particular process is endothermic. ये प्रोसेस में हमको हीट सप्लाई करने पड़ेगी. मतलब हम लोग जब बर्नर्स में से हीट सप्लाई करते तो क्या होता है, वो सिस्टम वो हीट एब्सॉर्ब कर लेती है. सो दैट हीट फ्लोज फ्रॉम surrounding to system through the boundary wall. So this is the endothermic process. Suppose we want to calculate the change in enthalpy at constant pressure and volume. How to calculate it in the gaseous state? As we know that in the gaseous state we are having some volume, we are having some gases being enclosed inside the. How to calculate the gaseous moles? We know that number of moles which are being enclosed. So let us say consider a isothermal process, means delta T, temperature will be constant. So in that case what will happen, V1 will be the gaseous reactant volume and V2 will be the gaseous product volume, and N1 is the moles of reactant and N2, here must be N2 is the moles of product. So as we know that what is the ideal gas equation? Ideal gas equation हमको सब पता है. So what is the ideal gas equation? It is given by the PV is equal to nRT. So this is the ideal gas equation. PV is equal to nRT. Okay. But as our volume is being variable, volume change होता है. Suppose कोई कंटेनर में गैस लिया है और उसको हम लोग हीट प्रोवाइड कर रहे हैं एट कांस्टेंट प्रेशर पे, तो क्या होगा, हीट प्रोवाइड कर रहे हैं तो उसका वॉल्यूम बढ़ेगा, एक्सपेंशन होगा, तो उसके साथ साथ उसके मोल्स भी बढ़ेंगे. So suppose दो गैस हमने कंबाइन कर ले. So what will happen? We can write this particular equation for initial state. PV1 is equal to N1RT and PV2 is equal to N2RT. So we can combine these two terms at one side. PV2 minus PV1 is equal to N2R2. जो constant term है हम लोग बाहर निकाल देंगे. So V2 minus V1 हम लोग क्या लिख सकते हैं, डेल्टा V, and RT constant पकड़ेंगे और what is N2 minus N1 will be delta N. So instead of that P delta V जो टर्म है उसको हम लोग क्या लिख सकते हैं, डेल्टा nRT. So as we know that P delta V, as actually we know the definition, delta H is equal to delta E plus P delta V. So instead of that this particular P delta V, we can also write delta nRT. So this particular equation can also become delta H is equal to delta E plus delta nRT. So depending upon the quantities which are being provided to you, you can choose which particular equation we have to use. Whether we have to use the equation delta H is equal to delta E plus P delta V or delta H is equal to delta E plus delta nRT. So these are the two equations which we can use whether if your pressure is being constant. So this equation will become like this. So you have two equations, either this one or this one. Now we are going to understand a new term that is being called as a molar heat capacity. So it is a heat capacity. So what we can say, it is the quantity of heat absorbed by system to increase the temperature by 1 degree Celsius, or we can say also to increase the temperature by 1 Kelvin. जनरली हम लोग टेम्परेचर अभी कैसे कैलकुलेट करते हैं, इंस्टेड ऑफ डिग्री सेल्सियस वी कैलकुलेट इन द केल्विन्स. सो इट इज़ द क्वांटिटी ऑफ हीट एब्सॉर्ब्ड बाय अ पर्टिकुलर मास ऑफ मैटर इन ऑर्डर टू इंक्रीज द टेम्परेचर बाय 1 डिग्री सेल्सियस. सो कोई भी सिस्टम हीट कितनी एब्सॉर्ब करेंगे वो किस पे डिपेंड रहता है, वॉट एवर द मास विच इज़ कन्फाइंड इनसाइड द सिस्टम, सिस्टम में कितना मास है उसके ऊपर डिपेंड रहता है. So it is directly proportional to the amount, that is being m. So heat capacity is the extensive property. Already I have explained. It is depend upon the quantity of mass. So it is being calculated as a joule per Kelvin. We can also write this quantity as a joule per Kelvin. So Q is directly related with the product of molar heat capacity into delta T. This same equation also we can write if we send this particular quantity here. So what is molar heat capacity is the ratio of quantities of heat absorbed per temperature to increase the temperature from T1 to T2 or T2 minus T1 also we can write here. Q divided by T2 minus T1. So molar heat capacity. Now we want to calculate the heat capacity for only 1 mole of gas. जनरली हम लोग रिएक्शन करते हैं तो उसमें मोल्स कंसिडर करते हैं. 1 मोल है, 2 मोल है, 3 मोल है. सो 1 मोल गैस का 1 डिग्री सेल्सियस टेम्परेचर इंक्रीज करने में जो अमाउंट ऑफ हीट लगती है उसको हम लोग क्या बोलेंगे, मोलार हीट कैपेसिटी. सो इट इज़ द अमाउंट ऑफ हीट एब्सॉर्ब्ड बाय यूनिट मास in increasing the temperature of 1 mole of substance by 1 degree Celsius at particular temperature. So molar heat capacity is directly related with the unit mass to increase the temperature by 1 degree Celsius or 1 Kelvin. So it is nothing but the unit joule per mole or Kelvin. As we are taking the moles, so here must be term introduced as a mole. Molar heat capacity depend upon the parameters, whether we are carrying out that particular process at constant volume and constant pressure. If we are carrying out that particular operation at constant volume, that term will be molar heat capacity at constant volume. That is being denoted with the sign CV. So what is CV? It is the heat capacity at constant volume and defined as the rate of change of internal energy with temperature. So whenever we are carrying out any particular process at constant volume, that is directly related with the ratio of change in internal energy plus per unit temperature. So this particular quantity we can also write. CV is nothing but change in internal energy per unit temperature at constant volume. So remember what is the equation for CV. Remember, volume is directly related with the internal energy, so it is nothing but dE divided by dt. And molar heat capacity at constant pressure. So it is the heat capacity at constant pressure is defined as rate of change of enthalpy with temperature. So at constant pressure it is affecting on the enthalpy, so we have to consider the enthalpy change. So how to calculate the Cp? Cp is equal to dH divided by dt at constant pressure. So remember, at constant volume we have to consider internal energy, at constant pressure we have to consider enthalpy. So these are the two terms which we have to remember. It is nothing but the ratio of quantity of heat absorbed per unit temperature. Okay, suppose if it is a Cv, it is nothing but dE divided by dt. If it is a Cp, it is nothing but dH divided by dt. So go through these particular terms, go through the equations, enthalpy and molar heat capacity. So try to write these particular equations in the notebook. Hope so you will understand. Try to correlate these terms with some examples. It will help you to understand. Thank you very much. See you in the next session with some another topic.